Hey everybody. I am not positive about this, but I think the number of the day today might be 31. And if it's not, we can figure things out later on. But I'm going to go with 31 and we'll see what happens. But a quick couple facts about 31. This is a puzzle. It's called the Tower of Hanoi. And how it works is you take one of these discs. We've got a side view of these circular discs, and you take one of them at a time. So I could take this top one off of here and move it here or here, doesn't matter which one, but I can only move one at a time. Also, if you take a disk and put it somewhere, you cannot put it onto a different one that is smaller than it. So if this one goes here, the next one would have to go over here. And then the next one wouldn't be able to go in either of those two spots. So the little one would have to move over onto the third one. And what this has to do with 31 is that if you have a 5 disk tower, it requires 31 moves to solve. And then if I have a circle with points on it and I connect those points with segments and figure out how many regions are made. So 1, 2, 3, 4, 5, 6, 7, 8. I'm just counting up all the, well, I guess the pieces of pizza, you might think of it. And if I look at the number of points connected to the number of regions with 2 points, of course, I divide this up. I'm only going to be able to make it into 2 regions. If I have 4 points, once I get done dividing this up, we'll count up the regions. I've got 1, 2, 3, 4, 5, 6, 7, 8. And if I put that all on a table, it looks like this. And so it looks like if I have 6 points, we would have 32 regions. But it turns out if you do this with 6 points, you end up with only 31, which is a little surprising because the pattern, it goes 2 and then 4 and then 6, sorry, 2 and 4 and 8 and 16. But what follows doesn't stick with that same pattern. The pattern turns out to actually be this. When it looks like it's just 2 to the n power, it turns out to be this 1 and then 2 and then 4 and then 8 and then 16. And then things change after that. And it goes with this formula instead for reasons that we probably don't want to go into right now. All right, well, what we're going to be doing today is very similar to what we have been doing. You have been taking 3-dimensional shapes and figuring out what the nets of those shapes look like, and then figuring out volumes and surface areas and all kinds of stuff with that. Well, what we're going to do today is instead of me saying this is how tall the shape is, this is the length and the width and the height, and you have to figure out the information from that, today we're going to switch things around and say, well, what if instead of giving you the volume and the surface area, what if I say the volume is this amount and you have to figure out what the dimensions are? Or maybe I tell you this is the surface area and we need to figure out how tall the shape is or how wide the shape is. So working backwards using the same formulas as in the past. Everything's still the same. The lateral area formulas are still the same. In fact, why don't I just write them on here just in case you haven't written them down in your notebooks already. The lateral area, the areas of the sides of a prism. We found out that we just take the height times the perimeter of the base. So the distance all the way around the base times the height of the prism. We said that the surface area was the same thing, except we add on the top and the bottom. And so the surface area is the lateral area plus the base twice. So add 2b, or not 2b. No, that's definitely 2b. And then the volume, the amount of space that would fill up a prism, we're going to find the volume by taking the area of the base. And remember, I'm using an uppercase B to stand for the area of the base, not the length of the base of one of the sides or something like that, but the area of the base, and multiply that by the height. These are the same formulas that we've been using. We're going to use them again in problems that look like this. The volume of this rectangular prism is 120 cubic centimeters. If the height is 6 centimeters and the base is 4 centimeters long, how wide is the prism? And then we'll also talk about the lateral area once we figure that out. All right, so for this problem, this is how I did this one. I said that the height was 6, so I can go ahead and label that as 6. It says that it's 4 centimeters long, so the length along here is 4. And I'm trying to figure out this, how wide is the prism. And so formula, volume is the area of the base times the height. I'm using the volume formula because that's what we're given. The volume is 120. And so I say that 120 for the volume is equal to the area of the base times the height. The area of the base is just this rectangle on the bottom, 4 times W, and then the height is 6. So I plug everything into the formula, into the equation. Volume 120, area of the base is 4 times W, and the height is 6. And the rest of this is just a little bit of algebra. I divide this side by 24 because 4 times 6 is 24. I divide this side by 24 because that's how algebra works. And we end up with 5 on this side and W all by itself on that side. So I've got a width of the prism to be 5 centimeters. And then to use that and figure out the second part of this question that asks what is the lateral area, this is where I'm going to break this thing up and take a look at the net. Now I know that this is 6. Well, I was told that this was 6. That was 4, and we just figured out that this length was 5. And so if I break this up around the sides, I've got 4 and then 5 and then 4 and then 5, and the height of 6. And if I think about this like a cereal box, these are the sides, this is the front and the left side and the right side. Then I've got the top and the bottom. But if I'm looking at the lateral area, all I care about is this big rectangle. So here's that perimeter of the base, 4 plus 5 plus 4 plus 5. The perimeter is 18. 6 is the height of the prism that we were told in the first place. And since I'm looking for lateral area and not total surface area, that is it. Or if you want to just do all 4 of these, 6 times 4 is 24, and 6 times 5 is 30. If you want to just do this problem that way by adding up all of these sections, that's going to work also. 24 plus 30 plus 24 plus 30, it will add up to our answer, which is 108 square centimeters. And then the only other problem I want to take a look at with you guys is a similar type of question, working backwards. The base of a triangular prism has side length of 6, 8, and 10. So maybe this one is 6, and that one is 8, and the longest one is 10. Now, something significant to notice here is that in this triangle, it's hard to tell what's the base and what's the height. We need them to be perpendicular. But 6 squared plus 8 squared equals 10 squared. 6 squared is 36. 8 squared is 64. And 36 plus 64 is equal to 100, which is 10 squared. If this didn't work, then I would have to tell you what the height is. I didn't say the base and the height of this triangle because we've got this Pythagorean relationship. 6 squared plus 8 squared equals 10 squared, which means this is a right triangle. That's a pretty big deal. Anyway, it says that the surface area is 168. So we want to find the height. This time they gave me the surface area. The surface area formula says that the surface area is equal to the lateral area plus the 2 bases, the area of all 3 of those sides of the prism wrapped around it, plus the areas of the 2 bases. And so I plug in what I know. I know all 3 of these sides, so I know the perimeter of the base. That was given to me in the statement of the problem. So the perimeter of the base, 6 plus 8 plus 10, times the height, which I don't know yet, and then plus the 2 bases. And since these bases are triangles, I do 1/2 base times height, where the base can be 6 and the height can be 8 because they are perpendicular. Or if you say the base is 8 and the height is 6, that's going to work out okay too. Either way, 6 times 8 divided by 2, plug that in for the area of the base. And so my equation, 168, that's the surface area. 6 plus 8 plus 10, that is the perimeter of the base. Height is the one I don't know. And then after I plug 6 times 8 divided by 2 here, I've got 2 times 24 to give me 48. Then I do a little bit of algebra, subtract 48 from both sides of the equation, divide both sides of the equation by 24, undoing adding 48, undoing multiplying by 24. I get a height of 5. So when in doubt, I guess go with the height of 5. It's not always going to work, but I guess it did for the first, or for the 2 problems we're doing today. And then this problem also asked for the volume of the prism. And we've done most of the work so far. The volume of a prism, volume for any prism, is area of the base times the height. We already did the area of the base, 6 times 8 divided by 2. That was base times height divided by 2 for the triangle, multiplied by the height that we just spent some time figuring out. And when I multiply that out, I get 120 for the volume of that triangular prism. So there we go. That's working backwards. The homework assignment does have a couple problems where you're working forwards. These are the dimensions, find everything, and then a couple examples where you're going to be working backwards. Coming back next time, we're going to be taking a look at some more specific shapes. We got to talk about pyramids and cones, and then we'll also have to talk about spheres before we're done with this. But we'll make sure we're okay with each one before we move on to the next one. As always, if you have questions, get a hold of me through email or on Schoology or in the Google Hangout, and I will, well, see you virtually a little bit later this week. Have a great day.